1.3 in Algebra 2 now. Solving linear equations. Okay, once again, a topic that you should know from pre-algebra, a topic you should know from Algebra 1, a topic you should know from geometry, and now that we're doing it again in Algebra 2, it should be even sweeter and even easier for you to do it. So let's see what we can do here. Linear equation, it has the form ax plus b equals c. And what that means is you have a variable of x, you have an equal sign involved, and you have some numbers. And those numbers can be decimals, fractions, integers, natural numbers, whole numbers. It really doesn't matter what they are. Okay, there must be an equal sign. That is the concept of an equation. It has an equal sign in it. So when we're sitting there trying to do word problems, like most of you will be doing, you will forget to put equal signs in when we are trying to solve these equations. When we say the word equation, we mean it has an equal sign. And linear equations do not have exponents as well. Eventually, when we get to quadratics in Chapter 5, we will have exponents in the equations, but currently we will not. And they cannot equal 0. So basically what we mean by that is a linear equation, you can't have a 0 for a. Otherwise, there's no longer a variable, and if there is no variable, then it is no longer an equation. So 2x plus 3 equals 7 is an example of one. Negative 6s minus 8 equals 5. That's an example of an equation.
By the hammer of Thor.
Properties of equalities. If a equals b, then a plus c equals b plus c. So what does that mean to you? If 3 equals 3, and I add 7 to both sides, I'll get the same answer. That's what it means. So I'll still get 10 on both sides. Subtraction. If a equals b, then a minus c equals b minus c. What that means is if two items are the same, like 6. If I have 6 on both sides, and I'm taking a 4 away on both sides, I'll get 2 on both sides. Multiplication. If a equals b, then a times c equals b times c. So what that's saying is, if I had 3 on both sides, and I multiply both sides by 4, I would get the same answer on both sides of 12 and 12. And division. If a equals b, and you divide by the same number c that's not 0, you get the same on both sides. So if 1 equals 1, if I divide both sides by 3, I'll get the same answer on both sides, as long as 3 is not equal to 0.
I look good. I mean, really good.
So we got to solve this problem.
Hey, everyone! Come and see how good I look.
When you are sitting down looking at this problem, I know that there is fractions, and I know for some reason, somewhere way back in the day, I don't know if it was someone must have scared you into thinking that fractions are your enemy and they are horrible, but this problem is not that difficult. Okay, so let's sit here and take a look. We need to get rid of anything on that side that's not related to that n. I'm trying to get n by itself. So in order for me to get n all by itself, I am going to subtract a 6 onto both sides first. The reason why I'm subtracting, this is addition, right? The opposite of addition is subtraction. So when I do that, these cancel out. 13 minus 6 is 7. So this is what I'm left with. N over 7 equals 7. We have a fraction. Remember opposites. The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division, so the opposite of division is multiplication. So, because this is divided by 7, I need to get rid of this 7. So to get rid of a fraction on the bottom, I need to multiply both sides by that 7. If I multiply by that 7 on both sides, I can get those 7s to cancel out, and 7 times 7 is 49.
I call top.
Sorry, I already called it in my head.
What? No, you can't do that. This doesn't count.
Example 2, variables on both sides.
You're in Jazzsville now.
Now, there are many ways to do this. Some teachers try to sit there and say to you, this is the only way you can do this problem. And the reason they do that, it's not that I'm cutting on them, it's just they're trying to make it easier for you. Because at a younger age, trying to understand this stuff, it can be very challenging. I'm telling you right now, because hopefully if you're in Algebra 2, you should be a little more advanced and you should understand what I'm getting at. But there are many ways to solve this problem. I could subtract a 4n to this side. I could subtract an 11n to this side. I could add 15n to this side. Or I could add 1 to this side. Either way, any way you want to start this, you're okay. Okay, so my point is, any one of those 4 items you want to move first, just move it. It doesn't matter. Okay, we'll go from there. So I'm going to choose the 15. I'm just going to add 15 over to this side. Okay, no problem. So I chose to add 15. Why? Because it's minus, so I'm going to add 15. So when I add 15 to both sides, those cancel out. I still have a 4n left over on this side, an 11n left over on this side. Negative 1 plus 15 is 14. Okay, now that I did that, I only have one option. I narrowed down my choices. I went from 4 things I could do to now I only have one thing I can do. I need to get all of my n's together on the other side, right? I don't want to push this over here because then I have everything on the same side of the equal sign. So now let's move those 11n's over. Since this is a positive 11n, I'm going to subtract 11n onto both sides. So by me subtracting 11n, 4 minus 11, negative 7n. So I have negative 7n equals 14. That's negative 7 times n. What is the opposite of multiplication? Division. So let's divide by negative 7. The reason I'm dividing by a negative 7 is because I'm trying to get n by itself. So I divide by negative 7. 14 divided by negative 7 is negative 2. So n equals negative 2 is your answer.
All right, Mr. Smart Reporter. Showing off. Figured out how to work the Google on the intranet machine.
Okay, so when we come back here, we will finish up 1.3 on solving the equations. Some of these it might take a little more and a couple more steps to do and distribute and everything. I just want to make sure that I have enough time to really center in there and go through them in detail. So when we come back here, we will finish up on 1.3.